Hi, my name is Kristen, and I'm going to be talking to you about Power BI, which is a data analysis tool that I would like to see more of in the animal fields. I'm going to go over what it is, compare it to Excel, talk about its strengths and weaknesses, and demonstrate how I've been using it to analyze animal data. So Power BI stands for Power Business Informatics. It's a data visualization tool that's been around since 2015. It's only available on Microsoft computers. You cannot use it on a Mac. However, it is free to use. You can easily download it from the Microsoft App Store, and it's built upon Excel, Power Pivot, and Power Query. In fact, it directly integrates Power Query as its tool for uploading and transforming data. Unlike those, however, it does not require a subscription fee. There is a paid element, which I'll get to later. It's a graphical user interface, or a GUI, with backend scripting capabilities. This being a GUI, it allows users to drag and drop data fields to build visuals. This can feel more intuitive to users than coding, lowering the barrier of entry to quick, reproducible reports. However, what's really cool about Power BI and what sets it apart from other GUIs is that it still supports user coding capabilities, and it does so with its own native language. So this can mean that it'll be less buggy. Even cooler than that, it allows for the integration of R and Python, so you can embed your own custom visualizations and statistical models with those languages if you would like. As for spatial analysis, Power BI comes with its own native mapping tool, but it also integrates ArcGIS. Overall, I believe that Power BI is great for data exploration, for gathering preliminary insights, and for monitoring data in a reproducible way. Finally, for those who invest in the paid version of this program, Power BI Service allows for cloud-based sharing of reports, which can be great for collaboration. Notably absent from this list, please notice I did not mention statistical analysis. Statistics are a bit cumbersome to calculate in Power BI with DAX language, and therefore statistics can be better handled through R or Python integration. So the primary question is, of course, can Power BI improve data analysis in the field of primatology? To explore this question, I performed the same analytical tasks in Power BI and then in Excel. To test efficiency, I used Mousitron to count my click rates, keystrokes, and time to completion, and then I retrospectively counted the number of formulas that I used. To ensure that I was accurately measuring time to completion and click rate, etc., and not just the amount of time it took me to think through these programs, I ran each of these tasks 3 times from scratch and took the quickest score. In every case, this of course was my 3rd attempt. The data I analyzed for this experiment was collected in 2023 in Huaycacang Wildlife Sanctuary, and it was part of my master's thesis. The data focuses on a single group of white-headed gibbons. I collected behavioral data on just the adult female, and then I recorded the sleeping tree characteristics of the sleeping trees used by the entire group. This data was supplemented by lunar data from datetime.com, and weather data came from worldweather.com. The weather data was collected in a town about 25 miles away from the field station, so it should be considered approximate. So for the first analytical task, I built upon one of the focuses of my master's thesis, which was to compare the characteristics of sleeping trees among individuals in the group. I aimed to build pie chart visuals in Power BI and Excel and show the individual variation in 2 tree characteristics, one being canopy thickness and the other being liana density. And then I wanted to visually explore how these choices or these sleeping tree characteristics might change or be affected by meteorological or lunar variables. And then finally, as a second analytic task, I built an activity budget for the adult female. So, exploring tree characteristics in Power BI and Excel. I began with Power BI, and in just 10 minutes, I was able to build this report from scratch, which allowed me to quickly explore my data. I spent less than a minute uploading and transforming my data. This is what the interface looked like. I had already scrubbed it for my thesis, so for this demonstration, I was basically just making sure that the data types were being correctly read, and then I was replacing any errors. For example, I had a few columns where instead of a null value, the word excluded was written, and so the program gets angry when text values are found in numbers columns, so I had to take care of that. And then I spent roughly 20 seconds creating the relationships between the spreadsheets, you can just drag and drop data fields in Power BI to define relationships between these spreadsheets. It's super, super simple. And so here are my Mousitron stats in the upper right-hand corner, and those are counting from the time I started uploading the data to the moment I took a screenshot of the dashboard. All of the keystrokes were from typing out graph titles and copying and pasting items with keyboard shortcuts because I used 0 formulas in creating this report. The number of clicks included formatting clicks just to make sure the page looked pretty and achieve the color scheme that I wanted. So this report utilizes data from 3 distinct spreadsheets. It dynamically filters the pie charts of the visuals showing the sleeping tree data based on slicers I created with the weather and lunar data. I also added a card visual in the upper right-hand corner so I could keep an eye on my sample sizes. Using these slicers allows me to play around with different variables and see on a preliminary level how my data is being affected. So for example, I can click on the filter for when it's raining, and then I can see that maybe these gibbons might be choosing to sleep in trees with denser canopies on days when it's raining as opposed to not raining. And then I can do the same exploring with wind gusts. So maybe on days where it's windier, the tree canopy thickness, the trees had denser canopies. And I could even do this with my lunar data too. Using Excel, it took me more time to make these 6 graphs than it took me to create that entire Power BI dashboard. So based on this, I knew I needed a refresher in Excel. So after a thorough investigation, I found that I could create dynamic dashboards or dynamic visuals in Excel using a feature I was previously unfamiliar with, the data model tool. However, even on my quickest attempt, it still took longer for me to do this in Excel than in Power BI. It required more keystrokes, and then in the end, I was still not able to achieve exactly what I wanted. There was no way to insert a card to read my sample size, and then for wind gusts, there wasn't any way to make this read as a continuous variable. I could only have the option to show it as distinct values in tile format. So as far as results, Power BI took less time, it required fewer keystrokes and clicks, and was able to support different visuals that Excel did not. Surprisingly, for Excel, I did not need the XLOOKUP and VMatch formulas that I was expecting to have to use, and I was able to achieve defining relationships between the data just with the data modeling tool. But it still took longer and wasn't able to do as good of a job as Power BI. So when creating an activity budget, it's really simple to do this in Power BI to show overall percentages of observed behaviors, but it's a little bit more complicated to do so when you want to show behaviors averaged out by day. But it can be done very quickly once you have your own code. So if I want an activity budget that calculates mean daily percent of time spent engaging in each behavior, I can reuse my own code that I wrote for a previous project. This was a code that I wrote several months ago for work, and I was able to seamlessly integrate it into this distinct project just by making a few minor adjustments. So the top code transforms my data into a usable format, and then the lower code creates the error bars. And since I had my own code already written, I was able to create this graph in just 2.5 minutes. I used 2 formulas, one for transforming the data to build the graph, and the second formula for the error bars. In Excel, I achieved the same graph by using a combination of power pivot and cell referencing formulas. It took me almost 8 minutes on my speediest run-through. In comparison, Power BI was much quicker to use because of the option to paste previous code. It also required fewer keystrokes and clicks and used less formulas, although that part's debatable because the data transformation code was so long and complicated. But I will say that Power BI is also more forgiving. For example, if I want to pull out a specific behavior and then recalculate the graph in Power BI, this can be done with just 3 or 4 clicks. In Excel, you'd need a carefully structured, formula-driven sheet that would take a higher level of expertise to build and maintain. I wanted to show an example of what a dashboard might look like at the very end when you pull everything together. So I've got some maps here as well. I can click on different behaviors and see where they were engaging in those behaviors on the map. I can even look at the moon and see how moon is affecting activity budgets. and canopy or tree scores, I can look at these tree graphs, and then if I'm interested in a specific tree, I can just click and I can see where it is on the map. Those 2 trees were observed on 4 days, and that's where they were as far as the location. I can also click to see on days when it was raining at the time of sleeping tree entry, and look at how temperature affects everything, etc. And then finally, I just want to show you how easy it is to manipulate your graphs. For example, let's show this one. I have the activity budget here, and if I want to see how lunar phase is affecting the data, I can just pull it in as part of the legend. Then I'm going to get rid of any behaviors that I'm not particularly interested in, just to make the graph easier to read. And then I have this lovely graph that shows, complete with error bars, different rates of resting, and I can see that maybe on a full moon day, the adult female is resting less than on a day when there was not a full moon. And this is daytime activity, of course. So in conclusion, I love Power BI and I hope you do too. And we still have time for questions.